Hello everyone, my name is Jonier Pinales. I'm part of the Security Evaluation of Encrypted Databases team. Today I will be doing an introductory video to our project, the problem that we have and the solution that we implemented. Steven Caceres will be doing the next video, and then we'll switch between videos 3 and 4. So the problem that we're trying to address is a very big problem that is happening right now in the computer science world, security. And as you guys know, cybersecurity is becoming a really big thing. So security is a really big issue, especially database security. In this case, not too long ago, a database of social security numbers with millions of records got broken into, and a lot of social security numbers got stolen by hackers. And this is a really big deal because now our information is out there, our social security is out there, our name is out there, our credit cards are out there, and they're being used for malicious purposes. So as a computer science, we believe that it's our job to create systems that are more secure and protect the information to a standard level. A solution that has been implemented for years is a system developed by MIT called encrypted. The solution follows the paradigm that data should be encrypted before you store in a database or store on disk. The way they do this is by using different types of encryption. Now, what happens is whenever you use a really strong encryption, then you kind of reduce the amount of queries that you can run against the database. For example, if you create a random encryption, then pretty much we cannot do any type of queries against the database except select all records. encrypted tries to solve this by combining encryptions to support different types of queries. For example, they have homomorphic encryption, which is a type of encryption that allows operations to be run against encrypted data. There's also deterministic encryption, which allows two encrypted values to be compared against each other. There is order preserving encryption, which allows data to be ordered in a specific way, and that way we can do things like greater than or less than. And there is a special type of encryption called text search, which allows text to be searched in the encrypted information. So encrypted tries to encrypt the data before it gets stored, and that way, if any hacker were to get database root access, all he sees is encrypted information and not the actual values that are in the database. This system is very secure because it combines different types of encryption into different layers, and that way it protects the information really well. But there has been recent papers that have shown that this database and specifically the encrypted values can still be decrypted using different types of attacks. Our project was to take these systems and go through these papers and run the attacks against the database and against the encrypted values and see if we were able to obtain any information. The specific attack that we chose was frequency analysis. Frequency analysis is a type of attack where you create a histogram of the columns in a specific table, and after the histogram is created, you have an auxiliary database that is similar to the one you have, and then you compare the frequencies between the two databases of the encrypted and the decrypted clear text database, and then you can kind of see what the values are. This attack, even though it's very old, is very powerful because there are a lot of systems out there that have similar databases because they might be developed by the same company or might be from the same institution. For example, if we're talking about medical records, two different hospitals might have very similar records because the way the database schema is set up and stuff like that, and the values are also the same. It also happens when you have, for example, student records. Two different universities might have the same type of records, and that's how you can do frequency analysis with an encrypted column. So pretty much, if your institution has encrypted data, but another institution doesn't have encrypted data, and that information gets leaked, then your information is at risk too. So that is frequency analysis, and that's the attack that we chose to run against this database. We were able to run it, and we were able to recover the information, the encrypted information, and it was a pretty big deal because this system is currently being used in different types of industry. So for part 2, our implementation to solve the problem was to insert fake data, and by inserting fake data, we can kind of flatten the histogram to a point that the hacker histogram that he gets is pretty much flat. The way we implement this is by parsing every insert query. When we extract the different values that are being inserted in a specific column. Then we calculate using a flat histogram algorithm that I'm going to show in a little bit. We calculate how much data has to be inserted at a specific point. This is the flat histogram algorithm. It's a very simple algorithm, but it makes sure that at any point in the database, the values of our columns are in a flat histogram. So we implemented this, and after that, we had to kind of filter the results because the client doesn't need to deal with all these fake results and stuff like that. So what we did in the proxy, we kind of, when the results come back, we filter the results, and that way the client doesn't see the results. We do mainly in proxy processing because if we were to filter at the SQL level, then that will mean the fake column that we create will peel down to a deterministic encryption, which will be leaking another histogram, and then hacker will be able to figure out what the fake data is. So we keep the fake column at random at all times, meaning there's no leak. That was our solution, our implementation, and it works really well. Whenever we run frequency analysis again, we're not able to obtain the data back. We pretty much got a flat histogram, and we were not able to assume anything about the data. So this is it for our introductory video to our project and our solution, and I'll see you next video. Thank you for watching.